Hello, friends, students and parents. I think you're welcome to my Math Mistake Clinic, episode one. This is the first episode, and we designed this to help students navigate uh, around some common math mistakes that students normally make. Okay, so today's episode, the first one we're looking at is place value confusion, where students misread uh, numbers. Students oftentimes misread numbers. So that's what we are looking at. And then hopefully we'll be able to help students in this regard. All right. So you are welcome again. Like I said, my name is Dr. Kazeem Okosun. I am your host. Today we are looking at the most foundational mistakes that students make, misreading place value. Let's fix it together. So students often think that the size of a digit determines uh, the, the value instead of its position. Okay, the position actually determines the value. All right. For example, so saying zero point 0.5 is bigger than 0.25 because 5 is bigger than 2. They just assume, okay, because 5 is bigger than 2, uh, that is why 0.5 is bigger than 0.25. They need to understand the logic behind positions. Okay, thinking 4,052, 4,052 is they read as 4,052, but reading it as 4552. Students skip the zeros. Most times they skip zeros. So why it happens is that students look at digits, not positions. They look at the digits, not positions. Okay, they read numbers left to right like words. They skip zeros without understanding the function of that zero. Okay, so they don't understand the function of the zero. All right, let's quickly go to teaching time and to help students understand the place value. What does that mean? A digit's uh, value depends on where it sits. Okay, not the digit itself, but where that digit sits, its position. Let's break down these three examples. In 843, this 8 is standing in the position of 100. So, which means your 8 means 800. But in 84.3, 8 is now standing, because of this decimal right here, this 8 is standing in the position of 10. 8 times 10, so your 8 will mean your 80, because that is the position. So in the last example, you have 0.8, and then you see your decimal before 8, right? So this 8 is now standing in a different position, which means you are having your 8 over 10. So this is exactly what this is saying. 8 means 8 times because of the position. All right. We have same value but different. We have same digits, sorry, 8. We look at the digits 8. So, but the 8 is in different positions. So they have different values. All right. Decimal reminder, just to remind us, 0.5 actually means 5/10, which means you have your 5 over 10. So, and the 25, 0.25 means 25 over 100. So that's just a reminder. Remember, if I need to make this fraction, I need to consider the number of movement that I make to shift the decimal 1, 2. So if I put my 1 here, I move 2 places, that is 0, 0, I add 2 0. So it's 25 over 100. So since tenths is bigger than hundredths, your 0.5 is bigger. Because if you look at this, 5 out of 10 is almost, that's about 50%, half of the total. But if you have 25 over 100, so it means that this is greater than 25 over 100. Yeah, thank you very much. Okay, so now let's see what do we have next. If I need to look at examples, want to look at my examples and solutions. So let's compare 0.6 and 0.56. 0.6 and 0.56. All right, so this is becoming very interesting. 0.6 and 0.56, what is the mistake students make? Students just assume your 0.56, they look at 56. They are not look at the position, they say 56 is greater than 0.8, greater than 6. So because of that, they assume 0.56 is bigger than 0.6 because they just look at 56 greater than 6. So the correct analysis, because you have 0.56 has two decimal places, if we rewrite both to have the same number of decimal places, we just need to pad 0.6 with 0, so it will be 0.60. So if you now compare digits, remember this is sitting in position of 10, so this is like 6 over 10. Because we are only comparing 5 and 6, so I'll have my 5 over 10. So if you have 6 out of 10 and 5 out of 10, which one is bigger? So you can now see clearly that this 0.6 at the end of the day is bigger than that other, that is bigger than 0.56. All right. So that is bigger than that. So that's why we compare digits by digits. All right. Okay. One more examples. Let's see. So that's why that example 2. Read and expand 4,507. Okay, students make mistake and say 4,057. They skip the zeros. So 4,507 is the correct thing. All right. So because if you look at this 4, comma, your 4 is sitting in position of thousands. This 500 right here is sitting in the position of hundreds. This 0 is sitting in its position of tenth. And you have your 7, which is the last digit right there. So this is 4,500. Of course, because it's 0, 10, you say 507. Okay. Example 3, which is larger, 3.09 or 3.9. Okay. Students say 9 is bigger than 0.09. That's how they say. So 3.09, they assume is bigger. They just assume that. So add zeros so that we pad the 3.9, to pad it with 0 to be 3.90 as it is right here. Then you can compare your 0 and 9 and be able to say 3.9 is bigger. So this is in the position of 0 over 10, and this is 9 out of 10. So this is bigger. So you can then say 3.9 is bigger than 3.09. All right. Well, so finish. Which number is bigger or larger? 7.004 or 7.04? Remember, we need to compare positions. You are not looking at 7 because that is fine. We have those as whole number. So we need to look at the first digits right here, 0.7.0. This 0 is sitting in the position of 10. This will be in 100. This will be in thousands. So this is like you have 0 over 10 for the first 0. Second 0 will be 0 over 100. And the 4 will be 4 over 1000 because of that decimal. So the second one will follow the same pattern. So you have your 0 right here to be 0 over 10. Then this is 4 over 100. And then the last 0 here will be 0 over thousands. So if you compare digits to position, this is fine. This is fine. And you'll see that your 4 over 100 is bigger than 0 over 100. So it means that 7.04 is bigger or larger than 7.004. Let's go a quick recap and then close. We'll meet you next episode. So what you need to do is to look at position, not digits. Not digits. Add 0 placeholders to compare. Like if you have 0.5 and you need to compare with 0.65, just add 0 so that you have the same number of the decimal place. Decimals follows tenths, hundreds, and thousands. Zeros are placeholders, not decoration. Okay, in closing, thanks for visiting Maths Clinic, Mistake Clinic. If today's lesson helped, share it with your student, parent, and teacher. Download the practice sheet, subscribe, and remember, every great maths mind made mistakes first. See you next episode. Thank you very much for being part of this tonight. Take care and God bless you.